Hi, I'm Chris, and in this video we're doing another problem using ratio test. So if you haven't yet been introduced to ratio test and you want an explanation of how it works and when to apply it, take a look at one of our earlier videos, link shown here. But for right now, we're going to take a look at a slightly more advanced ratio test problem. So for ratio test is going to be a way of testing convergence of a series using this formula. And here, we're going to test, as n approaches infinity, we're going to test the value that we have for n squared times 2 to the n plus 1 over 3 to the n for that series. And we want to see what's going to happen as n approaches infinity. So in this case, we're going to plug in n plus 1 for n, which is going to be our top term that we see there, the a sub n plus 1. So that would look like this. N plus 1 quantity squared times 2 to the n plus 1 will be n plus 2 all over 3 to the n plus 1. Then from here we're going to divide by the original term, which means this original function that we started with here. We're going to divide by that. And if you're dividing by a fraction, it's the same as multiplying by a reciprocal, which is what allows us to do 3 to the n over n squared times 2 to the n plus 1. Now I'm going to tidy this up a little bit and try to make it look just a little bit more user-friendly. So here, to start canceling things out, people have different preferences on this. For right now in this, I'm going to go ahead and FOIL this out just because I think for later on it's going to be a little bit easier to see what the ratio of our coefficients would be. So this will FOIL out to n squared plus 2n plus 1 times. And then 2 to the n plus 2, if you separate those out, it's the same as saying 2 to the n times 2 squared. If you're not comfortable doing this, then you might want to go back a little bit and take a look at your exponent rules so that you know how to split up those additive exponents. We're going to do the same thing in the denominator here. 3 to the n is the same as saying 3 to the n times 3 to the first. When it's 3 to the n plus 1, split that up, 3 to the n and 3 to the first. Multiply those together, and then times 3 to the n over n squared times 2 to the n times 2 to the first. Now we can cancel out quite a bit. So here's where we get to go from a very complex looking expression to something that's much more manageable. Here we're going to cancel out 3 to the n. We're going to cancel out 2 to the n. We're going to cancel out one of these 2's. So 2 squared over 2 to the first will just give us a 2 on top. And when we distribute this 2 to everything in parentheses, what we're left with is 2n squared plus 4n plus 2 over 3n squared. Now if you notice on this, for a little shorthand, I dropped the absolute value symbols. The reason we're allowed to do that is because if you look at the possible values for n equals 1 to infinity, which basically means if you're plugging in any number between 1 and infinity in this problem, you're only plugging in positive values, and all of these would result in positive results. So every number in the series is going to be positive, which means we don't have to worry about using the absolute value symbol. So we're able to drop those if everything's going to be a positive number. So when we do this to find the limit as n approaches infinity of this expression, and I'm just going to rewrite in the limit as n approaches infinity down here. It's there the whole time. It's just shorthand to write the function itself without dropping down the limit every time. But here, to simplify, when n approaches infinity, as long as these degrees are the same, then it doesn't matter what else is there in the expression. For the numerator and the denominator, you only care if the degrees are the same about the ratio of the coefficients. And this will equal 2/3. And if we compare that over here, 2/3 is less than 1, which means that this series will be convergent using ratio test. So hopefully, if you've had a chance to get introduced to ratio test and now practice it on a more challenging question, that it's starting to click and starting to become a little bit more clear. If you still have more questions, please feel free to check out our other videos or visit us online at sandersontestprep.com. Thanks for watching.